Okay, so we are determining that for this experiment the specific heat of these metals. So the first thing that you will need to do, and we are going to use a constant cap calorimeter, what we described in class, in lecture last time. We are going to use a metal, and we are going to use these two equations. The first one says that is the first principle thermodynamic that says that energy is not created or destroyed. So if you have a system and a surrounding, the sum of the heat released by the system is gained by the surrounding and vice versa, so that the sum of the system, the heat of the system, the heat of the surrounding is always equal to 0, okay? And in order to calculate the heat exchange between the system and the surrounding, we are going to use this equation. Q equal, the heat is equal to the mass of the species of which we are measuring the heat, the specific heat of the species, and the change in temperature, delta T, that is given by T final minus T initial. So I'm going to assign you to each of you one jar of these metals. You don't know what are these metals. You need to write down the ID and the physical property, meaning is it shiny? What are the size of the pellet? Everything that you can think of. Okay? So color. Then you're going to heat up the metal that's been assigned to you in a big test tube, such as this one. You're going to use between 25 and 35 grams, says the procedure, but it doesn't have to be exact. It has to be approximate, but weighted in the analytical balance. And the variability of the mass of 25 or 25 depends on the weight of the metal, the density of the metal. The more dense is the metal, the more you have to weigh or the less you have to weigh. What is it? You have to weigh 25 for the heavy metal or for the light metal?
More dense you have to weigh.
For the more dense you have to weigh? More. Okay. So you're going to put your metal in a test tube. You're going to heat it up and have the sensor not inside the test tube because the metal becomes really hot and it will change it will ruin the sensor. But as close as possible to the test tube, okay? Like we did for the other experiment, for the experiment 11. So wait until the water boils and wait until the temperature stabilizes itself. You should read the T max, the temperature, the maximum temperature that the sensor can reach, which is going to be also the initial temperature of the metal. Then while the water is boiling, you're going to warm up a coffee cup calorimeter. And what you're going to do is, you're going to prepare a coffee cup calorimeter. You're going to weigh 20 grams of water, always in the analytical balance. So please record all the significant figures after the decimal point, all 4, okay? And then put the water in the calorimeter. You have 2 holes in your calorimeter. One in which you should have your steering system. There is going to be a thermometer, and one in which you have your sensor. So you will read the temperature of both tools. The steering system, which is also a thermometer. Make sure that you choose a thermometer that has a continuous line. The ones that have an interrupted line are broken, they don't work, okay? And you cannot read the correct temperature. So read the temperature of the water with this thermometer and with the sensor. Once the boiling, the temperature for the chips has reached its maximum value, you pour the hot metal into the coffee cup calorimeter, and you measure the T final of the metal and the calorimeter and the water together, right? So they're going to be the same, the final temperature of the two species, which is the T max that you can read for the two together, okay? And is equal to T final of the metal and T final of the water. Once you've done this, how many times do we have to do this? Once, twice, 3 times? How many times? 3 times. 3 times in which we have accurate, actually precise measurement of the temperature. What does it mean? That you don't run all the lab and then after you dismantle everything, you say, are these temperature consistent? No. The temperature has to be equal to plus minus 1 degree Celsius. Okay? So then you perform your calculation. Here you have the equation to calculate the heat of the water. You know the mass is 20 grams. You know the specific heat of water. You know the initial temperature of just the water before you put the metal. And you know that T final, that is the temperature, the maximum temperature that the water and the metal reach when you were heating them up. Okay? Then what you do is you have the heat of the metal that's given by the mass of the metal that you are able to measure for each single run. The specific heat, which is what we want to calculate, and delta T. We said that we measure between 25 and 35, so for each group it will be different. S is unknown. T final is again the same T final that we have for the water. And T initial is the initial temperature that we measure with this sensor when we were heating up the water with the metal. Because we know this for the first principle thermodynamic, we can solve for S, writing that the mass of the water times the specific heat of the water times delta T is equal to negative the mass of the metal times the specific heat of the metal times delta T. You have all these values except for this one, so you solve for the specific heat of the metal. Okay? Any questions? All clear? Okay, so let's get started.
For experiment 9, we're going to be using the unknown metal number 56. Record any characteristics you see throughout your observations of the metal. First, we're going to be measuring our sample for our first trial. So let's turn on. I'm going to pick the paper. I'm going to tear it. And we're going to add approximately 25 grams of this unknown metal. Record to the appropriate number of significant figures for the first trial. This is the mass of the unknown metal for sample 2. This is the mass of the unknown metal for trial 3, so record to the appropriate number of significant figures. Okay. So we're going to be needing 20 grams of water to the calorimeter. So I'm going to measure it out. This is here. Alright. Now record the mass of the water inside the calorimeter to the appropriate number significant figures. So this is trial 1 of experiment 6. So first we're going to record the initial temperature of the water in the calorimeter, which has roughly 20 milliliters, and also the initial temperature of the hot metal in the water. So, did you record this one? Okay. So first we're going to extract the hot metal. Place it in the calorimeter.
You know, you hear the papers and I was looking for the redox reaction. No. You know?
I think so.
Is it there?
Now we're going to add it to the calorimeter.
Not here.
And you record the maximum temperature of the hot metal in the calorimeter to the appropriate number of significant figures, which is in channel 1. And then we're going to record as well on the thermometer. This is the mass of the water in the calorimeter for the second trial, so record the mass to the correct number of significant figures. This is trial 2 of experiment 9. So first record the initial temperature of the calorimeter, the water in the calorimeter, and then the initial temperature of the hot metal in the water, and also on the thermometer as well. Okay, so I'm going to erase this. Now we're going to add the hot metal. And now we're going to stir it. Now record the temperature to the max temperature to the appropriate number of significant figures. Okay. This is for trial 3 of experiment 9. So this is the mass of the water inside the calorimeter. So record it to the appropriate number of significant figures. Okay. So this is trial 3 of experiment 9. So first record the initial temperatures of both the water in the calorimeter and then the metal in the hot water. Get it? Okay. First we're gonna erase this. We're going to add the unknown metal into the calorimeter. We're going to stir it.